Hello everybody, I'm Sap Anderson from Autodesk. Now this is going to be a very interesting attempt of making a kind of a course in writing OSL shaders because I don't think it's that hard. So let's just step right into it. Beware, this is basically unedited and one take kind of thing, so there might be flubs and mistakes, but here we go. Lesson number 1, basic syntax and stuff. But what is OSL? Well, OSL is the open shading language. This was written primarily by Larry Gritz over at Sony Pictures Imageworks, and it's really a language that is specifically made for shading. We built it into 3ds Max 2019, which is a really cool thing. OSL might not be completely perfect, it has its flaws, but hey, it's what we got, and it's the only really viable open source shading language out there, so yay. To learn OSL, if you know C and C++, or maybe HLSL or GLSL or any of these languages, the syntax is very similar. So knowing some basis of that can be good, but it could also trick you because there are some differences that might trip you up. So let's look at something incredibly basic in OSL. We deal with variables. Variables are named things which you store values in. And they have a type, they have a name, and you can have an initial value, although this is optional. And by the way, every statement in OSL is ended with a semicolon. This is inherited from the C language, so you'll see a lot of semicolons at the end of things. So let's take an example. Float is a data type, basically floating point value. You think of it as a decimal value like 3.5 or 39.5 or whatever is a floating point value. You can have a name, say Bob, and an initial value, in this case 15. So now by typing this in OSL, we have created a variable named Bob, which is contains float values, and the start out value that we start out with is 15. Integers exist also, so here we declare a variable named Ted and put 23 in it. You can never put 23.1 or 23.7 in this because it's an integer, so it will just end up be 23. Integers are faster and more compact to store, but in OSL, honestly, with shading, we mostly work with float variables, not really integers that much. There is strings. So here's a string called Sally, which we set to the string hello world at first. String constants are surrounded by little by the quote marks. Strings are used in OSL for things like file names that reference textures. We won't go deeply into that, just showing that it exists right now. Then of course there is the data type color, which we'll use a lot. Here I declare a variable named mauve, which is of the type color. And I set it to default. Now, the default for complex types like colors look a little different. You see, for float it was just a value with some decimal point in it. For int it was just a value, and for strings it was a value in quotes. But for the complex types, we actually use the type name and parentheses and then a list of values. 3 values. This is the red, green, and blue value of the color. It's similar for the data type point, vector, and normal. So here I have a point named center, which has some value, a vector, and a normal. I will go a little bit more into the difference between points, vectors, and normals in a later class. So here's some example what you can do with some variables. For example, we go back to declaring a float named Bob. That has the value of 15. We can declare something without the default value. It actually gets the value 0 when we do that. And then we can say Steve equals 52. So you can do that on a separate line. Once you have declared the variable, so the OSL know that it exists and has a name, you can just say, the variable equals something. You could also say, use an expression on the right side. So Steve equals 5 plus Bob, and Bob was 15, so now Steve will have the value of 20. And basically what we had here, 52 gets thrown away, and now it has the value 20. This one confuses people that thinks programming languages are mathematical expression. This looks, because they look like equations. But equations in mathematics, the equal sign means that the both sides are equal. That is not what the equal sign means in programming. It actually means an assignment. So we could read this as Steve equals 52 means we assign the value of 52 to the variable named Steve. We assign the value of 5 plus Bob to the variable Steve. And here we assign the value of Steve plus 1 to Steve. And up to this point, Steve was, as I said, 5 plus Bob, which is 20. So this will mean that the new Steve will be the old Steve 20 plus 1, so 21. You might see a lot of these when we are working with variables where you want to increase over loops and all this kind of stuff. So don't be afraid. This, to a mathematician, this looks weird and like untrue, but think of equals as assignment, and that helps you a lot. You can do all at once, so we declare a new variable called Jimmy, which is Steve plus Bob divided by 12. Parentheses are used to group expressions in which order. Now, division does happen before addition, so these parentheses are actually not necessary. And you can make a point called somewhere. And again, when you take the complex type, you need to put the point and the parentheses there in the list of values. So now I use the Bob, I use the Steve, and the Jimmy as the X, Y, and Z coordinate of the point. So this is like super basic how you can work with variables, assign them values, assign them expressions, declare them and assign them expressions. You can create new variables from values of the old ones, etc., etc. The next concept that is good to know is a function. A function is some piece of code you can use more than once, like a reusable bit of stuff. And the basic syntax of declaring a function looks like this. You have a return type, you have the name of the functions, and then you have the list of parameters that each have a type and a name, etc. Can be any number of those, all separated with a comma. And then you have these little curly braces, and between the curly braces goes the code that is what the function actually does. Example, we can say a function that returns a float. We call it add two numbers, and parameters are a float A and a float B. And what the function actually does is return A plus B. And don't forget the semicolon. This means when we somewhere else in the code want to do this, add two numbers. Of course, this is a silly example because you can add two numbers with plus, but it's the concept we're talking about here. So somewhere else in the code, when we used it, it looks like this. We assign to some other variables the value of add two numbers, and then within parentheses we plug in the parameters. So here in this case is 13, and Q, we assume Q comes from somewhere else, some value we already had. What this effectively means, that when you see this line that says add two numbers parentheses, is as if we're kind of jumping up here to this thing, and this value gets plugged into A, that value gets plugged into B, and we do this, so A plus B, which effectively is 13 plus Q. This is returned, which you can think of as this like falling out the front end of the function here where the float is, which when we're looking at the place where we use it, it's kind of falling out here and ends up in the X. So 13Q ends up here, going there, and it falls out, return makes it pop out in the front to end up here. There is a different way to write functions where we don't use a return value. It looks like this. Now it says void, and now you see we added a third parameter that is said to be an output float C. And we changed this line to, instead of saying return A plus B, we say C equals A plus B. Because a function which is void means nothing, it returns nothing. It doesn't have a return statement in it. There's nothing it returns. So the difference here, if we flip back to the previous one, when we used that function, the result kind of fell out of the front of it, so we say float x equals. For the other case, we need a variable, we need a float to put it, but then we call just add two numbers with the inputs and the outputs. And in a sense, 13 and Q gets plugged into A and B. We run this line C equals A plus B. The C kind of jumps out through this output and pops up in the third one here, X, which gets stored in the float variable X. So this is an alternate way of writing functions with outputs declared in the parameter list. It's especially useful if you want to return more than one thing, because a function like the previous kind, which has a return type of, say, float, it can only return a single thing, whereas a function of this style, you can have multiple outputs and compute multiple things in a function. Now, shaders. A shader looks pretty much identical to a function with outputs, with two differences. One difference is the type is always shader, and each of the parameters to it need a default. This bit is new, equals default. Now, since this can end up really long with a shader that takes a lot of stuff, we sometimes break it up like this. We just put new lines here and we indent this with the tab key to make this stand out. So we have, these are the parentheses around the parameter list. Here's the list of parameters, just broken out one per line. This is purely typographical. This changes nothing in the function. The compiler doesn't care if you write it like this or write it like that. The key thing to think, though, is that you are in a list of stuff within regular parentheses. That means the list is separated with commas. It's very easy to do the mistake here of thinking of this as statement, think there should be a semicolon here, but no. These are separated with commas, and since it's separated, you actually don't need a comma in the last one, although the compiler actually won't complain if you accidentally put a comma here. Let's take a real-world example. Shader named add two colors. The first one, we have a color A, and we set the default, which is a color 010, which means green. Color B, color 100, which then gives it the default of red. And an output color called result, and we have to set a default even for the output. Normally I just set them to equal 0, because immediately in the code we'll do something like this, result equals A plus B. And now we have written our first shader. It's a shader that takes two color inputs and returns them added. If you put it into max, it will look like this. You have two inputs, A and B, and the node shows two inputs. They default to green and red, and they will return A plus B. So we see here in the resulting example here that A plus B, green plus red, is yellow. So it's default right off the bat to returning yellow. And we have written our first shader. Let's do some practical examples. So let's try this in actual Max. I find my OSL map and I just drag it into the material editor. And I open up the OSL source code editor right here. And we're going to get rid of this completely. There's an example shader in there, which is a good start, but we're going to ignore it for now. And we're going to write our first shader. Let's put in a nice comment and say our first shader. Very nice. So, shader, the keyword, the name of the shader, my first shader, parentheses, and parameters go there, and I break them apart on lines already to make it easier. And then we need the curly braces within the actual code goes. So right here we have our very first OSL shader that does literally nothing. But it doesn't quite work, because we try to compile it, you'll get an error, say, hey wait, there's no outputs. Max actually requires outputs on the shaders, or you can't use them. So to make it work, we need to add an output. So what we need to do, output has to be first, and then the type, color. Let's call it result, and don't forget the default, just set it to 0. F7 for compiling, and we can close this error window because it's happy now. And now we have a shader that returns black. Of course, in the code here, which is the code that's actually run, we can give result a more interesting value. So if I say 1 here, don't forget the semicolon, you will see it now returns white. I can give it a color value, 001, which would be blue. Don't forget the parentheses after the type and the 3 RGB values. It's blue. Nice. Of course, if you want to play with and understand variables a little more, we can now inside the body of the function make some variables. So say a float TED equals 0.5, and then we can say that we return TED instead. Now you wonder what happens. Result is a color and TED is a float. Well, what happens is it simply assigns all the RGB values to the value of TED, because TED float only has one value. So if say 0.8 here and recompile, we'll see it goes brighter gray, and 0.2 and compile, it becomes dark gray. Now what we could do, of course, is play some more with this. So say we float f equals 1 and do some expressions here. So TED is, you know, return the result as TED times f. Obviously nothing will change now because multiplying with 1 gives the same result. But I could change this to 5, and 5 times 0.2 obviously is 1, so it's white again. Now, one interesting part, now I'm just playing in the code and typing values, but that's not really interesting. What we want to have is inputs. And if we just take this float f equals 1 and just cut it from here and put it up here, and remember one thing, this is no longer a statement which is ended with semicolon, it's a list of the parameters and they are separated with comma. By simply doing that and hitting F7 to compile, we'll notice that now f is a parameter, f is now an input, and I can actually now tweak f, and you will see that it's actually tweaking the result here. Very nice. So let's change TED. Let's do this. Color A equals red, and change this to A times F. So now we have a red which we can tweak the intensity of by changing this parameter F. We can even say let's make this also a parameter, so let's plug it up here. And again, remember, no longer a statement, it's a part of a list, so we need to have a comma. And I'm actually going to make 2 of them. So we have a color B, which I will default to green, like this. So now we have 3 inputs. Hit F7. See, we have red, we have green, and we have F. And right now result is A times F. So it goes from black to red. This is all really nice. But let's say what I want to do now is to make a shader that interpolates between color A and color B, such that when this is 0, I want to see color A, and when this is 1, I want to see color B. Well, right now when I set it to 1, I see color A, because obviously we're just returning A times F. And at 1, I of course want it to be color B, so I guess for starters we should say B times F instead, so it's green now. And yes, we have no green at 0 and we have full green at 1. That's great, but I also want A to show up at 0. So how do I do that? Well, I can add A to this, which I multiply by 1 minus F. 1 minus F will be 1 when F is 0, and it will be 0 when F is 1. So let's try this. And we notice, yeah, it's red, and now it turns black. What's wrong? Why is it not working the way we want? Well, the reason is we forgot something important. This is actually computing B times F plus A times 1 minus F. Because the order of precedence is such that multiplications happen before additions and subtractions. So instead of taking A times 1 minus F, which was our intent, we take A times 1 minus F. we fix that with parentheses, like this. Boom. Now I have something that interpolates between red and green. Really cool. Let's assign this to a material and test this in our active shade and see what we see. And we play with it and we notice, hey, what happened here? Ooh, something is really wrong. Well, it turns out when we're outside the 0 to 1 range on this parameter, things kind of break down because, you know, we're multiplying stuff with negative values and we're assigning basically the diffuse color of this material something which has a negative value. Now, negative values and shading doesn't go well together, so you get these horrific artifacts. So we want to fix that somehow. So how can we fix that? Well, one way would be to use an if statement. So let's say if, and then there's parentheses after that, we say if f is less than 0 or less than and equal to 0 even. What will happen then? Well, result should of course be equal to a, the first one. Don't matter how less below 0 we get, we just ever want it to be the first one. Result equals a. Does this fix it? If we check for the negative case, no. Why not? Well, of course, we set result to a and then immediately we do our calculation that is wrong. So one way to fix that is just to swap the order of this and first compute this and then has like an override. If it's, you know, less than 0, then fix it. So let's try that. And yes, now no matter how much we go below 0, it sticks at red and it doesn't break down and go crazy. We haven't fixed the top value yet though. So this still is wrong. So we try if f is greater than 1, then or equal to even, then we want the result to be b. And bang, now it works. However, this is not the absolutely most optimal way of doing it because I mean, first computing something and then saying, oh, in this case, just throw that away and set a different value. And in that case, throw that away again and set a different value. So a cleaner way to do it is to use the else statement. And then for if statements, you tend to do this. This is, again, these indentations and stuff I'm doing is purely for our human eyes to kind of see the context of things. In certain languages like Python, the indentation actually matters. It does not in OSL, so it's purely graphical. But I want to say something like if f is less than or equal to 1, we want to do that. Else, if f is greater than 1, we want to do that. Else, and then we're going to steal this line up here and move it down to the bottom. There we go. So if it's less than 1, do this and nothing else. But if it's not less than 0, we do that, check if it's greater than 1, and if it is greater than 1, we do this. But if it's neither of those two, we just end up doing this thing. And again, indentation is just for decoration. And it's important also for if statements. If you write them like this, you don't need any curly braces like this if there's only one line, because after the if you can have one statement exactly that gets executed. If there's more than one thing that has to happen, you actually have to put it within curly braces like this. So if I wanted to do something else, you know, I don't know, whatever, I need one more line, then this would need to be within the curly braces. By the way, if I try to compile now, it would report an error and everything is, and the shader won't run. So now we have a simple shader that basically interpolates between two values like this. And of course, these values don't have to be these fixed colors. Obviously, we can plug in something else like, you know, candy and checker as the inputs, and your spinner is now interpolating between candy and checker. And we can even plug noise into the F input, and now there's a noisy mix between candy and checker, etc. So this simple code can do complex things by hooking it up to other stuff. Let's disconnect that for simplicity now. Another interesting thing is this. We're going to talk about functions now. Like I said before, I described functions really quickly and said that a shader looks a lot like a function. I'm going to now show you a slightly alternate way of doing the same things by making my own function. So, because this looks like something you might need a lot, you know, mixing two values and making sure the mix function is not outside the 0-1 range and this kind of stuff. So let's make a function that does that. So what should this function return? It should return a color. What we're going to call it is, let's call it safe mix. It's a mixer that is safe in the sense that it doesn't break down if the mix value is below 0 or above 1. It needs some input, one color and another color, and the mix value. So let's say, okay, color one color, and color another color, and a float mix value. There we go. Those are the parameters, and curly braces for the content of the function. So what does this function want to do? Well, we want to do effectively the same thing we did in the shader here, but there's a few things we can do differently. For instance, these tests with the f less than or greater than 1, we can try that. So we say if mix value in this case is less than or equal to 0, return. This is a new statement you use in functions. One color. And the interesting thing with return, that means that this function code stops running here. Nothing after return will happen. So we actually don't really need the else construct we used here, because it's implicitly when an if statement comes to return, we're kind of falling back out the front of the function here and returning the value. If mix value is greater than or equal to 1, we say return another color. There we go. And in the general case, we want to do the mix. So return, let's see now, another color times the mix value plus one color times 1 minus the mix value. Don't forget the semicolon. Compile. Bang. Okay. Now, we're not using this yet. We just made a function. So we go down here, get rid of all this stuff, and simply say result equals safe mix, my brand new safe mix function with A and B and F. Let's try it. It should still work exactly the same. I tweak this. Above 1, still green, no weird things. Below 0, still red, no weird things. Absolutely working the way we want. So this is using the safe mix function. So effectively A and B kind of get stuck into one color and another color, and F gets stuck into mix value. If it's less than 0, we return the first color. If it's greater or equal to 1, we return the other color, and otherwise we mix the values. There is another way we could do this also, because OCell doesn't let you build your own functions. There's actually a ton of them that already exist. For instance, you look in the OCell specification, you'll find a bunch of library functions, and there's one called clamp. Clamp will take a value and make sure it's not below something or above something else. And that sounds really useful in this case. So we can do this instead. Instead of these if statements, we instead declare a new variable, float safe mix, which is our safe mix value, where we call the clamp function. You see it turns blue because it's a predefined function. And we're clamping the mix value from 0 to 1. Don't forget the semicolon. So safe mix will now be 0 for every point where mix value goes below 0, and it will be 1 for every time it goes above 1. But in between it will basically locking 0 and 1 as the min and max value. Whatever comes in will basically be blocking it to that. So we simply change the code here to use safe mix instead of mix value. We forget that, otherwise it breaks. Safe mix. Compile. Still does the same thing, I hope. Yep, still works. No problems with big or small values. So this is, of course, another way to do the same thing. We're clamping the value first. And of course, if we look carefully in this PDF, we see there's already a function called mix, which basically does exactly what we want, mix one from the other. So this whole thing about writing this stuff, 1 times this plus the other times 1 minus this, we don't need to do that because there's already something called mix. Mix, one color, another color, and mix value. And now we can, oops, of course, I made a boo-boo, safe mix, of course. We want to use the safe mix. There we go. So now, because that's not built into the mix function, be clear about that, it will actually break for those values. So here we go, now it's working again. Very nice. And of course, you're not forced to make a new variable like we did. We could just do it this way. Take this and place it here. This will still do the same thing. And you can look at it as if you take the parenthesis after clamp, we see here the parameters to clamp is the mix value 0, 1, and that kind of gets replaced with the result. And if you think about the mix function here, it has 3 inputs, this one, and this one, which is this whole expression. So this is also a legal way to write this. Now, it could be beneficial to do it the other way with the variable, because particularly in the case we had before, if I undo back to the original code for a few seconds, this one, you notice that we use safe mix twice. And of course, this is not a very complicated function, but if you write it this way, you're certain that clamp only happens once and that value gets stored in safe mix, and then we use this value twice. If I actually were to cut and paste this to both places where safe mix happens, the same computation might happen twice. Maybe the optimizer deals with it, but I'm not completely certain. And shading is really sensitive to being performant. So you want to write your shaders as intelligently as possible and don't do stuff unnecessarily. Don't do a bunch of math that you don't really need to do. So we have made our first shader. We have made our first little function called safe mix. We have played with calling some existing functions like the mix function we were just using. There we go, much prettier. And that's pretty much it for class number 1, I think. We have some more stuff coming up in the next one about using actual parameters from the scene and fun stuff like that. But this was your first step into writing a tiny little shader in OSL. Enjoy.